to make plans to control the rate of climate change, to make plans how to adapt to climate change. It's pretty clear that we've got some pretty severe rate of climate change. And it's very clear that unless action is taken, the planet is going to experience some very severe problems. So it's really a very good issue to talk about. And the recent 2018 report of the Intergovernmental Panel on Climate Change, IPCC, showed that more recent data shows the rate of climate change is increasing instead of much faster than was assumed when the Paris Agreement was met when the Paris Agreement was launched in 2015. So that approach in 2015 called for a more gradual reduction in climate and greenhouse gas emissions. And it's abundantly clear now that the rate of action that the 2015 agreement that had nations agreed to is insufficient to protect us from almost catastrophic results by the end of the century. Greenhouse gas emissions increased in 2017, they're increasing in 2018. There is as yet no clear idea when they will stop increasing, much less when they may start decreasing. So this is going to require unprecedented changes in human activities in order to reduce greenhouse gases. Greenhouse gas emissions in half by 2030 and to almost zero by 2050, which are quite large challenges. The United States government has predicted that damage from climate change could reduce the economic activity of the United States by 10% at the same time the population is increasing. Pretty severe impacts. So one of my topics is land use issues related to climate change. How governments decide and regulate the use of land within their countries is going to have a major impact on what happens with climate change. A very famous article in Science, one of the best journals in the world, said that land use is going to make a huge impact on world biosphere, perhaps the biggest impact of any other activity. Obviously, reducing greenhouse gas emissions is in the same ballpark of a huge impact. And here's an example. We look at two cities. This is Atlanta, in the United States. This is its footprint. This is Barcelona in Spain. The two cities are approximately the same population, 5.3 million, 5.3 million people. Yet the land use is entirely different. So Barcelona is 27 times more densely populated than Atlanta. Atlanta emits 11 times more greenhouse gas emissions than Barcelona. And the reason is this dispersed pattern of development, mostly single-family, detached houses, as opposed to dense pattern of urban development, causes huge transportation movement. And transportation, with the vehicles we have, emits a lot of greenhouse gases. Other land use issues that are certainly very important are deforestation, which is happening a great deal, especially in the tropical zones, the Amazonian basin and other tropical areas. And agricultural land use has been mentioned a couple of times already this morning. A lot of agricultural activities emit methane and nitrous oxide emissions, which are two of the most significant greenhouse gases. So I also want to talk about infrastructure issues which are related to land use and have a powerful impact on climate change. With increasing rates of population growth and population movement from rural areas to urban areas in countries around the world, there's a growing need for new infrastructure to protect the concentrations of populations. And what we don't want is our roadways that we're building be eroded by climate change, and produce sea level rise, and storms, and other activities. So we need robust planning processes to plan and complete construction projects in a timely manner with our infrastructure, yet avoid the need to retrofit and replace them before the end of the project design lifetime. So planning for infrastructure in coastal areas where sea level rise and erosion are going to have huge impacts are especially difficult because sea level rise is caused by global warming. The most recent climate change projections of sooner impacts of climate change will require dramatically new approaches to plan for sea level rise and the inundation of coastal cities. Instead of gradual change, this change is happening much faster than we thought. At some point, it is likely that it's going to be necessary to make plans to relocate millions of people to higher ground as a safer long-term response to climate change. Short-term hardening of infrastructure to protect storm surge, it may be inadequate with predictions for climate change and sea level rise. That's going to require huge expenditures of funds for coastal infrastructure in new locations, moving the barriers to storm surge inland, and new infrastructure to support these populations. You're losing millions of people. You have to build new infrastructure for them, new housing, new employment, all sorts of infrastructure. And there are substantial difficulties in making such plans. We have no experience with that rapid change in such large volumes of change. There are legal problems, financial problems, equity issues, which there is presently no experience dealing with. It can be quite a challenge. In addition, some of the older infrastructure, this is the barriers on the Thames River that protects London from storm surge. It was built in the 1970s. These collapse and sink down below the water in normal times and are raised up to protect against storm surge. Yet this hard infrastructure approach to protecting against the impacts of climate change and sea level rise are, in most cases, going to be inadequate. The sea level rise of 1 to 4 foot or more within the century will overwhelm some of this infrastructure that we have and actually trap water inside it, which is a problem. So really already in London, this was built in the 1970s, already they're now redesigning their climate change approach with what they're calling dynamic robustness, which aims to build flexible strategies that can change over time in response to new projections of what's going to happen. So clearly we've got to have plans on how to adapt to this changing environment and the changing world we live in. Countries of the planet must seriously and quickly develop and implement plans to avoid the most serious negative impacts. There still seems to be an agreement that it is technologically possible to plan for and enact changes to deal with 1.5 degrees centigrade of global warming, climate warming. However, there's widespread belief that these changes are politically unlikely. It is one thing for scientists and scholars to make accurate predictions of these things, quite another matter to have political change to respond to them. So So rapid, dynamic, planet-wide actions to control and adapt to climate change are urgently needed. The United States is planning, it estimates, the latest reports from the United States are reporting that it's cost many millions of dollars to harden coastlines, build new sewer systems, change farming practices as emissions continue to rise. And it's more difficult to do this and more costly as that happens. And planning will be needed to reload urban populations away from the coast. The United States is talking about a two-stage process, a dual strategy. First, to early adoption of methods that have a track record and there's confidence that they work. And secondly, to set up programs to start testing and deploying carbon removal methods, negative emissions, biomass plants, forest management techniques, carbon farming programs. Some of these have been spoken about earlier this morning: planting more trees to capture and store carbon in forests, adopting agricultural methods such as no-till agriculture to store carbon in the soil. Some recent research in the United States has found that the potential of climate change resolutions in the United States of conservation, restoration, improved land management interventions could offset as much as 21% of the country's annual greenhouse gas emissions under ideal situations, which are hard to achieve. The second stage of the United States strategy is to increase research on geoengineering approaches. So the nations of our planet need to test, develop, and deploy technologies by approximately 2050 to remove about 10 billion tons of carbon dioxide from the air each year. Currently, there are numerous approaches that are being proposed and being investigated, such as things as carbon dioxide approaches to remove carbon dioxide that is already in the air, using different forms of direct air capture. That uses, for instance, using giant banks of fans to blow air through a solution that contains carbon dioxide capturing chemicals. Other potential approaches include ejecting into the upper atmosphere particles that will reflect sunlight away from the Earth and control warming. So jumping to conclusions, there's a great urgency to reduce greenhouse gas emissions, and also there's a great urgency to remove carbon from the atmosphere, to avoid as many as possible of potentially negative consequences. Even a sense of great urgency, there's a need for careful scientific research to identify cost-effective approaches to preventing disastrous climate outcomes and to avoid unintended consequences. The 218 IPCC reports a clear warning there's no time to waste to develop for the world's nations to develop and implement plans to reduce global warming and to adapt to climate change.